Hey students, this is Mrs. Tran-Bloom returning to you guys with section 3.5, writing quadratic functions. There are three ways that you can write the same quadratic function. Each form shows a different feature. So the first one is the standard form. And as you guys remember, the standard form is y equals ax squared plus bx plus c. And this one, when it's in standard form, it shows us, right? It shows the y-intercept immediately. So y-intercept is when x equals to 0. And if x is 0, the ax squared will disappear, the bx will disappear. So you will have the y-intercept at 0, comma, c, whatever c may be. Then the second form here is y equals a times x minus h quantity squared plus k. Remember, this is the vertex form, so this shows us the vertex. And the vertex is obviously h comma k. Then the last form here is it's the intercept form. I just want to remind you guys too, sometimes we also say factor form. So intercept and factor form, it's the same, okay? So factor form is y equals, we take out the a in the front and then we factor it out. So normally in a quadratic, we would have two x-intercepts, so x normally, not all the time. So x minus the first root times x minus the second root. And this will show us, so shows the x-intercepts. And the x-intercept is when the y equals to 0. So we take the root number 1 and y is 0. Then we write root number 2 and y equals to 0. All right. So when we want to translate from the vertex form or the intercept form into standard form, we just use basic algebra skill, distribute, and use the order of operation to combine like terms. So let's try it, okay? In examples 1 and 2, it says, write each equation in standard form. And students, standard form is y equals ax squared plus bx plus c. Let's try to multiply these out and then put it in that form. So y equals 2 times x minus 5 squared plus 6. So what you should do when you see a power of 2, students, is write it out twice so we don't forget to FOIL correctly. So here we have 2 times x is going to give us 2x. 2 times negative 5 is going to give us negative 10. Drop down the x minus 5. Oops. Minus 5. And drop down the 6. And then now FOIL again. 2 times x is going to give us 2x squared. I'm sorry, 2x times x is 2x squared. 2x times negative 5 is negative 10x. 10 times x, negative 10 times x is negative 10x. Negative 10 times a negative 5, it's positive 50. Drop the 6 down. Now 2x squared is its only term, so there's not, we can't do much, but we have this right here that would give us negative 20x, and these right here that would give us 56. And that is in the ax squared plus bx plus c, and that is the standard form. Now let's try B. That's example 2 I meant. So example 2, we can FOIL these out first and then distribute the negative in the front, or we can distribute the negative and then refoil, okay? So it's really up to us. But in this one, let's do the distribution of negative. So negative in the front times x is now negative x. Negative in the front, that's kind of like negative 1, okay guys? So negative 1 times a negative 10 is going to give us a positive 10. So parentheses, drop down this x plus 8 and then FOIL again. So negative x times x is negative x squared. Negative x times 8 is negative 8x. 10 times x is going to give us positive 10x. 10 times 8, that's positive 80. So y equals, drop the negative x squared down because that's the only term. Those will give us positive 2x, and drop 80 down. And that is in the standard form of y equals ax squared plus bx plus c. So now, when we want to translate from standard form into vertex form, it is helpful to be able to complete the square. Yes, guys, we have already studied how to complete the square in 3.3. Perfect square trinomials are part of the vertex form. So if you need to, please go back to 3.3 3 notes. Now take a minute to write these steps down, okay? Translate from standard form to vertex form using completing the square. Step number 1, subtract c value from both sides. Step number 2, complete the square by taking the b value and divide it by 2, and then square it. And then after that, we want to add it to both sides so that way the equation will still be balanced. Step number 3, factor the perfect square. And step number 4, add the k value to both sides. Okay, so for this one, we are going to follow those steps, and then I'll show you another way as well, okay? Examples 3 and 4, write each equation in vertex form using completing the square. So currently, we are going to ignore this y value for now, and we are going to add it back at the end according to the steps. So first, it says move the 5 to both sides, okay? So now we have negative 5 equals x squared plus 6x plus blank. So whatever we are adding to one side, students, we are going to add it to the other side as well. Now side work, b value is going to be 6, and we want to take that and we're going to divide it by 2. That will give us 3. Okay, so half of b is 3. Then we want to do 3 squared, and that will be 9. 9, students, is what we are going to add to both sides. So whatever we are adding to the right, we have to add it to the left. Then on the right side, this is now a perfect trinomial. So we are going to factor it. And so this is x. If this is a plus sign, we drop a plus sign down. And this right here is really where whenever the half is. So if that's 3, this gets 3. Now on the other side, we have 9 minus 5. So that's going to be 4. And the step on the number 4 says add the k value back to both sides. So here's where we move it back to both sides. So when we move it back, we have equals x plus 3 quantity squared minus 4, and then this y value that we said, okay, let's just save it for now. We are going to check it in right there. And that is the vertex form. Now, for this one, because we have y to begin with, I wouldn't be moving the 5 to both sides. Here's what a second method is. So I'm going to drop the x squared down, drop the 6x down, okay? And then I do want to move the 5 still on the right side, just a little bit further out. Then I'm going to go in and add a blank space here. This is where we are still going to do half of b and then square it. This is where the 9 is going to go in. Well, but here's the part, guys. We just added 9 on one side of the equation. That is now imbalance. So to make it balanced, we are going to subtract 9 right away. Well, think about it. Adding a 9 and going in and minusing a 9, we're really adding 0. And it's okay to add 0 because it's not going to change our equation. So this is what, for me anyway, this is what I would do if I'm completing the square and there's a y equals. Then here is exactly like what we had above with the perfect trinomial and try to factor that out. This is, again, drop this x down, and whatever this half of b is, that's where it's going to go. And then this is negative 9 plus 5, that's going to be a minus 4. And guys, this equation right here is the same as that. So however you want to do it, whatever system is easy for you, okay? Number 4, we have f of x equals x squared minus 10x plus 8. And so for this one, students, I'm just going to do it my second method by moving the 8 all the way here. Then I'm going to go in and add a blank space. Remember, I can only add a 0, but we are going to manipulate this 0, okay? So your b value is negative 10. We are going to take half of that, so that's going to be negative 5, okay? Then we are going to take negative 5 and we're going to square it, and that's 25. We're going to add 25, but just like earlier, we said we can't just add 25 on one side of the equation. So we are going to go in and minus 25 right away to now really adding 0. So this is a perfect trinomial in which we can factor. So the factor of this is, okay, x, and this is a negative, drop down a negative. Half of b is negative 5, guys. So that's going to be where the negative 5 goes. Can you see that right there? So that's where the negative also goes right there. So x minus 5 quantity squared, And then this is negative 25 plus 8. That's going to give us a negative 17. And then box that up. Okay, so this sign right here, students, much match with that. Okay, and then this, whatever this is right here, that's where that is as well. All right, guys, but now completing the square is not always the easiest method, especially when we have an A value that's not 1. And then if the B value is not even, and the reason it's easy when the B value is even is because, remember, we take the B value and we divide it by 2, so take half. So what would happen if that's the case? Then we want to translate the standard form into the vertex form using the vertex itself. And remember, students, we've done this already on the prior unit. To find the x-coordinate of the vertex, we take negative, aka opposite of b, and then divide it by 2 times a. So that will give us the h value. To find the k value, we just plug it in. So this one said plug h in. And then to get the k value, then we're going to write it in the vertex form by just filling in the a, h, and k. So examples 4 to 7. Actually, can you guys fix this for me? We want to do 5 to 8 because 4 was already done above. So this is 5, 6, 7, and 8. Okay. So example 5 to 8, write each equation in vertex form using the vertex. So guys, example 5 right here is exactly the same as example 4 above, in which we were using completing the square. Let's use the vertex way to see if we come up with the same exact answer. Okay. So the vertex form, students, is y equals a times x minus h quantity square plus k. We want to rewrite it so all of our equations on 5, 6, 7, 8 to look like that. Okay, so let's identify a. Whoa, that pen's super fat. A is going to be 1 for this equation. H is what we're trying to find. B is going to be negative 10, and C is going to be 8. So according to the instructions, and remember, I want you to take a couple minutes here and write those 2 steps down, okay? I want to find the h value first, which is negative b all over 2a. And b is negative 10, so opposite of negative 10 is now 10 all over 2 times 1. So our h value is 5. Okay, h is 5. Then plug, if I can, plug this in, okay, to find your k value. So k value is the same as getting the y coordinate. So plug in 5, so f of 5 equals 5 squared minus 10 times 5 plus 8. 5 squared, students, is going to be 25 minus 50. Drop down the 8. 25 take away 50, that's negative 25. Drop down your 8. So this is going to give us a negative 17. And students, this is the y coordinate, so this is the k value. So let's fill it in. So we want it to look like this, right, guys? So a value is 1 times a quantity of x minus. H value is 5, quantity square. And then k value is negative 17. We can box that up. Or normally, if a is 1, we really don't write that in the front, students. And whenever we have a plus or a minus, then we go back and just make it a 17. And then box that up. So this or that is perfectly okay. All right, let's go and do example 6. Example 6, and again, let's try to find the a, h, and k first. So, oh, come on, dude. A equals 1. A, B, C first. B equals 9, and we want to write C is going to give us a 2. Okay, so first, H is always going to be opposite of B all over 2A when it's in standard form. So B is 9, so opposite of that is negative 9. 2 times A is 1, so 2 times 1. So this is going to give us negative 9 over 2. We will keep that as our simplest fraction. Then to find your k value, it's the same thing as plugging it in. So negative 9 quantity, negative 9 over 2 squared, plus 9 times negative 9 over 2. Drop the 2 down. From here, we know that negative 9 over 2 quantity squared is positive 81 over 4. And then a negative 9 times a positive 9. Now, if you have a fraction and you want to write it as over 1, so that way you can multiply the top 2 and the bottom 2, that's how you want to think of it. So negative 9 times a positive 9 is now negative 81. And then a denominator of 1 times 2 is 2. I will eventually make this, guys, into a common denominator of 4. So I'm going to drop down the 2 for now. 2 over 1. So let's go in and make this multiply by 2 because we want a common denominator. Oops, this is actually by 4. Okay, so if that's the case, this will give us 81 over 4 minus 81 times 2. That's going to be 162 over 4. And then we have 2 times 4. That's positive 8 over 4. Combine the first 2 terms, that's going to give us negative 81 all over 4. Drop the 8/4 down, so that's going to give us a negative 70. All right, so negative 73 all over 4. That's the simplest form in improper fractions, so we'll leave that. Remember, we want to now put it in the vertex form. So a is going to be 1. We will fill that in, times x minus h is going to be negative 9 over 2 quantity square plus k. K is a negative 73 over 4. Now again, we talked about this in example 5. If a is 1, we normally don't keep it in the front, and then the 2 negatives here would make it a positive 9 over 2 quantity square, and then the a positive and negative, we normally rewrite it just to show that would be a negative, and that is how we put that one in vertex form. All right, let's go to example number 7. Okay, so this one, students, a value is 3. B is negative 24, and C is 44. And again, to find the h value, we go negative b all over 2 times a. Well, b is negative 24, so a negative of that is now 24 times 2 times, divided by 2 times a. A is 3. So 24 divided by 6, we will have an h value of 4. Now we plug this in. Plug it in. All right, so y equal, which is really the k value, guys, is 3 times 4 square minus 24 times 4 plus 44. So this will give us 3 times 16 minus 24 times 4 is going to be giving us a 96. Drop down the 44. 3 times 16, that's going to be 48 minus 96 plus 4. Now 48 minus 96 plus 4, all of that's going to come out to be a negative 44. And this is the k value. So let's plug it in. Y equals a times, so a in this case, students, is now a 3. So we have 3 times x minus h is now 4 quantity square plus k. K is going to be a negative 44. We can leave this like this. If you don't like that plus and a minus, then we can rewrite it just like this, minus 44. So this or that is perfectly a-okay. Let's do one last example. Okay, this one, students, has a decimal, which normally when it's a decimals, I prefer to rewrite it as a fraction, because when we have fractions, it's a lot easier to square it, okay? Especially if you don't have a calculator. So negative 0.5 is exactly the same as negative half x squared plus 3x. Now students, as you can see, you don't have a c value, so I'm just gonna go in and fill in a 0. So this will allow us to say, okay, a is now a negative half, b is now a 3, and c is just 0. Then let's find the h value. H is going to be negative b divided by 2 times a. Now b is 3, so negative 3 divided by 2 times a is going to be a negative half. So negative 3 A negative 2 times a negative 1/2, students, is now a negative 1. So this will give us an h value of 3. Now we plug it in. G of 3 will give us the k value. So we're going to use this fraction right here because it's easier to square and multiply by half. Okay, so we are going to say, okay, negative 1/2 times 3 squared plus 3 times 3. This will give us a negative 1/2 times 9 plus 9. And this is going to give us a negative 9 over 2. Now we can straight up make this into a common denominator of 2 to give us an 18 over 2. So our k value, students, is going to come out to be a positive 9 over 2. All right, let's move it up a bit. So g of x, which is y, equals a value, students, is negative 1/2 times x minus h is going to be 3 quantity square plus k is 9 over 2. And we box that up. All right, guys, that's how we transform one to another.